vulnerabilities that we need to be aware of. Even developers these days, they need to be aware of these threats, let alone security specialists. So these are the minimal number of threats or the minimal threats that you need to be familiar with. So we started discussing this last time. These top 10 threats are maintained by this organization or open source projects called OWASP, which stands for Open Web Application Security Project. It's an open source. Every 3-4 years they update this list. And for the 2017, these are the top 10. We will super quickly go through them, explain each of them, and I will, if you have any questions, please stop me along the way. I'll have to go a little bit fast to make it within the 50 minutes we have. Okay, we already started talking about injection. I explained it last time, and I will just quickly recap. For injection, what you have some kind of interpreter on the server side. It could be a SQL server, it could be, let's say, a JavaScript interpreter. And from the user interface, the users are doing some data input. You're taking the data inputs from the users, you concatenating it with some code that you wrote yourself, and you submit both to this interpreter to evaluate. Now, if you do this, the user could type in some malicious code that you concatenate with your own code. And when you run it through this interpreter, it can create an attack. I think it's much easier. I already showed those of you who were here last time, I already showed you a demo. I will rerun it super quickly just to show you what this really means. So this is a vulnerable web application available on the web. You can download it and play with it. It has lots of vulnerabilities. So if I go here to contributions, what I'm expecting here is that we type a number. So instead of typing a number, the malicious user could type in here a command. And this command will be sent to the server. The developers are doing a lousy job. They are taking the input and passing it through an interpreter. And that's what's exactly taking place. What I mean here by an interpreter, just to show you quickly what it means. If I go to JavaScript, this is a JavaScript interpreter. It has a very quite evil function that you can pass to it any string. So for example, I can pass to it a simple computation, and it will go ahead and do it. So it takes a string and execute that string. So this eval, now it's considered as an interpreter. If I take an input from users, I should be very careful not to directly concatenate it with my own code, because that will be that can be an open door for injection. So I'll just show you here what I mean. If I can do here eval, and I do here something like there's a library in Java in Node.js called process.kill, and I'll say here process.pid. Yep, and I close this one. So if this works, this will terminate this terminal. Okay, and you can see it's gone. So eval is an interpreter. It takes in a string, so you need to be very careful. So in here, the developers, daily developers, instead of doing the right job for converting a string to a number, because when you submit something from the web, it arrives to the server as a string. If you want to do some computation on it, you have to convert it to a number. There is a function to do so. Again, I'll just show you quickly. Node. Yep. So if I want to convert from a string to a number, there is a function in JavaScript called parseInt. If I do this, it gives me a number. Okay. So what the lousy developer did, they used eval instead. Yeah. This also converts from a string to a number. But it opens the door for a lot of problems. So that's what happened. So the attacker, usually there is some input the user is expected to enter, and the malicious user comes, and instead of putting the data they need to put, they put a malicious code. So let me give you an example, exact same one, like for example, I do here process.kill that I showed you, and this will make a denial of service attack. This website will become unavailable immediately once this is executed. Now the server is gone, that's it. I have to call the administrator. If it's a critical, they have to come with their pajamas to the server room and restart everything. So it's very dangerous.
Parse it is not an answer.
Sorry? No, parse it, no. First of all, if I put in its string, this is a good question. If I put on it a string that is not a number, it will fail. It does not execute arbitrary commands. So let me show you. Here it is. If I do parse int and let's say, and I try to put here a non-number, it will say this is not a number, and it will not execute. It's simple as that. But eval will take anything and execute it. So you see here, denial of service attack. So injection, the reason why it is on the top of the list, because it's the source of all evils. You can use it to do denial of service attack, to steal sensitive information, to delete data, to change, to do so many damages that you can do. Okay, so that's why it is on top of the list, and it was in the top of the list of all versions of OWASP. Okay, so let me now restart the server because it was brought down by this injection. Just to show you one more, and then I'll move on to the next one. If I go here to contributions, I can even ask for certain files. Let me show you here. I can ask for all the folders in the current folder, and it shows me. Here are all the folders. This is injection could be one way how attackers manage to get into systems and download sensitive files or crack into database and access database content. I can even ask for one particular file, the content of one particular file. Here is the content of the file. It might have, you see, a crypto key. It can have some very sensitive information. I have access to it. That's why it is on top of the list, because it may enable other more serious attacks, other follow-up attacks after you do injection. So the idea is clear of the injection. So how do we prevent it? What's the simplest way to prevent this? Yes, we do input validation. The most important one, we do input validation. This could have been avoided. Here I'm expecting a number. I should check that the user gave me a number. I'm expecting, let's say, even if I'm expecting a string, it's like 5 characters or 10 characters, no more. So data validation is very, very critical. And you know, like, it is the last thing we think of as developers, especially under time pressure. You just let us make it work and move on quick. But it opens the door for a lot of problems. This can be easily avoided by validation, data validation. Also, it can be avoided by escaping some characters. Like, for example, especially in SQL injection, I have demonstrated this last time. In SQL injection, there is this single quote. You can make it harmless by putting in front of it backslash. It's escaping it. Or if it is, let's say, this is the password, you make it illegal. You make the single quote illegal in the password, for example, and so on. So it's all about mainly data validation to avoid such problems. Okay, so this is the first vulnerability. The second vulnerability is broken authentication. Okay, so broken authentication, there are many scenarios. Okay, the first scenario is the timeout is not set properly. Maybe the timeout is very long. What I mean by timeout, sometimes we log into a website and then we use that website, and especially in a public internet, maybe some shared computer, and then we close the browser and then we move away. Somebody can come in and open the browser, the session is still there. You know, we never press the logout. Although the logout is there, we don't use it. If you close the browser and you didn't log out, your session is still there. Anybody can come after you and open and access it. So at least the set timeout should be there. You typically 10 to 15, 20 minutes. That's the typical timeout applications put. The other one is session hijacking. You know, those of you who did some serious web development, you might realize when the user logs in, a session is created for them, and there is a session ID that is returned to the client. So that session ID you typically is stored as a cookie, and if some attacker managed to steal that cookie using maybe sniffing the network, then they can hijack the session, take over the session. So this can be avoided. So first of all, the first one can be avoided by putting a reasonable timeout after the user logs in. The second one can be avoided by serving the application through HTTPS. Then all the communication will be encrypted, and the attacker, even if they sniff the network, they cannot put their hand on the session ID. Okay, the third scenario, the passwords might not be properly encrypted or hashed. Like the developers, they collect password from users, but they didn't bother. They save them as plain text in a file or in a database. So if the hijacker, the hacker managed to access the system password list, they will get passwords in plain text. So that's another broken authentication scenario. So the last one is allowing users to put just simple passwords, easy to guess. So these can be attacks by brute force. So how can we avoid the last one? So enforce some complex password. Say 8 characters minimum, and you have to have a mixture, a lowercase, uppercase, numbers, and so on. And not only this, sorry?
Or we can limit the number of tries.
Yes, thank you very much. So if the number of trials, failed trials, exceeds certain threshold, typically 3, then your account is locked. So these are broken authentication scenarios, very common attack vectors that the attacker can take advantage of. The third one, the third vulnerability, is sensitive data exposure. Sensitive data exposure. What this means is, as a developer, you need to be aware where is the sensitive data in your application. And you need to make sure that sensitive data is taken care of through encryption throughout the system, whether in storage, when you are storing it in a files or in database or in or any other storage mechanism, whether you are storing it, whether it is in the network, transiting the network, or even sometimes if it's very sensitive, even in memory. You make sure that sensitive data is always encrypted. Okay. So another scenario of sensitive data exposure, especially for developers, when there is an error, they tend to provide lots of details about the error to the end user. They might say, oh, we failed to connect to Oracle database on this server, and they give the server name or the server IP. They are giving too generous information. Of course, they do this because it makes it easy to debug the application and to find out the error and to investigate and fix it. But it exposes the organization to attacks because you are revealing too much information that can be abused or misused. Another scenario that I can think of, let's say some sensitive information like credit card, you might put in the log, this credit card failed attempt of payment, and you put the credit card in plain text in some log. And maybe somebody analyzing the log, they might find that information in plain text. So in here, what I want to say here, the main thing is anything sensitive, make sure it is encrypted, whether it is in storage or in transit in the network. There's other things, when there are errors, just give a generic message saying, we failed, like processing of your request failed, please try again, or something like this. But don't give too much details, too much revealing details that can be misused against you. That's basically what sensitive data exposure means. You need to be aware of what is sensitive, especially financial information, private information, passwords, those typical critical pieces of data, you need to take care of them. Okay. This one, XML, external entities. Anyway, not convincing to me, but there are lots of legacy systems that are still using XML heavily. But modern applications, XML has been gradually kind of replaced with JSON as another data format. So what this means, maybe I try to explain it through a simple example. So let me see, maybe this one. Yeah, okay. So in XML, first of all, those of you not familiar with XML is a data format where I can describe a message and communicate the structure and the content. For example, just as a small example, I might have here a student object. So I have a student object, and I open the tag and close the tag, and within it I can define what are the properties of a student object. So I might have student ID, close the tag, open the tag, and then put the value, and then I close the tag. This is how XML looks like. It's very powerful data format. It communicates the schema of the message as well as the content of the message. Now, when this message comes along, especially between organizations, or they exchange messages through XML messages between them. So you can upload, you might send a message to another application, or you might upload an XML document to an application. So that application, what it does when it receives this, it will process this XML message or XML document. So when it processes them, there are some standard components in any language, Java or C# or Python. They call themselves XML parsers. They go through and process this XML document. They might validate it to make sure it complies with certain schema. They might use you might use an XML parser to extract information from the document and transform it to another format, let's say from XML to HTML, and so on. So what the attacker here does, they abuse the parser. The parser has some features that can be misused to become vulnerabilities. The parser, you can inject some kind of code in your XML document to ask the parser for example, in this case, I am injecting this in my document. And what I'm saying here, in this document, I have an element called foo. And this element, yes, there is an element called foo, and this element has another element called bar. And this bar will be, I'm asking, this bar will be the content of this file here. So what the parser will do, the parser will go to this location, which is private location within the network. It will read this file, and it will assign it as a sub-element of this foo. So what I mean by this, so this is kind of what is known as a data type definition. And this is the structure of my document. So here I'm saying this is foo, this is foo. I have an element foo, and within it there is an element bar. And this element bar is nothing but a resolution. I'll have to go to some file and read its content, and put the content of that file inside, like to replace this element bar. So basically the XML parser will blindly do what you ask it to do. what you asked. In this case, the parser will go to that file and read it and place the content of it instead of the element bar. And then basically you get the content of that file. Okay. Let me see if I have a better example here. This is another example. Similar. So basically what I'm doing here. Yep. Yes, here is another example. I think this one a little bit clearer. There is something called data type definition. So I am defining here an element foo. It could be anything. Any is a data type. There is a data type string, int, float, maybe not float, decimal, and then you have any. It could be any content. And in here, within this foo, I am defining another element, XSE. This is just a name. You can call it whatever you wish. And this is what will be the content of this XSE. I am asking, go to this file under ACT, password, and give me the content. So when this is parsed means when this XML document is processed by the parser will go and fetch the content of this file and return it to the requester. Okay, so it's not convincing to us as maybe modern developers because we don't use this legacy stuff. But just be aware of it. New developers, they don't use this stuff. They use JSON, which doesn't have this vulnerability. Okay, and this vulnerability has been fixed. Many XML parsers are aware of this. You can disable this feature in your XML parser. Even if you are using this legacy XML-based parsers, you can disable the ability to resolve. This is called entity resolution. You resolve an element by going to a file and fetching its content. Yeah. Okay. The next one, the fifth vulnerability in web applications is broken access control. There's a broken access control. Okay. Now, what this broken access control means? One scenario of this broken access control is known as insecure direct object reference. Insecure direct object reference. What does insecure direct object reference mean? Let's say you are in Banner and you are accessing your transcript. Okay. Now in Banner you're only supposed to see your own transcript only, not other people's transcript, not other student transcript. But maybe in the URL you will have there /transcript/student ID equal 1234, which is your student ID. And I'll say, oh, I wonder how Sarah is doing. What's her, or any of you, how she's doing. Is she doing better than me or worse, or what's her secret? And you can go, what you do in the URL. Just change the URL to her ID, because you know her ID. You put the URL and hope the system will show you her transcript. Yes? So this is very common. Again, the lazy developers. The developers are one of the lazy creatures out there. And then basically what they do, they just assume the users are not curious. Sometimes it's not malicious, it's just curious. And they will not go and change the URL. Because the URL sometimes is very inviting. It's showing you very meaningful names of parameters, and the parameters there inviting you to go and change them. Now, this is very common attack. Developers, they don't check. Usually, they don't check that you are only supposed to see your transcript. So basically, how we can fix this?
Not showing ID in the URL.
No, it's fine. We can show it. It's fine if we want to.
There is not using meaningful parameters.
No, we can, because there is a dilemma here. Because as developers, we want to keep things meaningful for maintenance and even for users. They can see this. No problem. So what is a better way?
Specific URLs are accessible.
No, not really. It's just much simpler.
We shouldn't reference it directly.
No, it's fine if we reference it. It's fine.
But not directly, so the user can directly access it.
No, it is okay. You can directly access because sometimes you need that. in some scenarios. So all you need to do is validate the authorization. Whenever the user requests some URL with some parameter, check whether they have access to what they requested or not. So don't check at the function level, also check at the parameter level. The user only have access to his or her transcript, not other people. So it's very simple check. You just say if the student ID of the requested transcript equal to the student's ID of the current user, allow them. Otherwise, deny access. Simple as that. Yeah? Because at the end of the day, you need to pass the parameter. And by the way, even if you say, I don't want to show it in the URL, you might show it, you need to post it at the end of the day. Those of you familiar with web development, you need to post it to the server. You might use the post request. But an advanced attacker, they can also generate a post request. Those of you familiar with the Postman or any other tool, you can generate a post request very, very easily. So not showing it in the URL does not solve your problem. Even if you do post, you are still subject to this broken access control. So the best way to do it is to do what? Verify the authorization every time the user accesses the URL. Validate that the user really allowed to do the action they have requested. Yes? Yeah, verify authorization to all access objects, files or data. Yeah. So the second scenario is very similar. Like you have direct object reference. You allowing user to access objects directly by putting the ID of the resource they want to access. Again, in here, whenever they access this, make sure they have access to it. Make sure they have access to it. Or another way to do it, maybe one of you mentioned it, is you maintain a kind of a reference map. So the ID that you show to the user will be something random, very hard to guess, and then you have a mapping table that maps these random values to the real value. So the user will be very, very hard for them to guess them. So for example, you might have a long random number that you put in the URL. So very hard, even if they change, they will not fall into something meaningful. And then for each random number, you maintain a map to the real parameter value. That's another way of doing it. But checking authorization every time the user requests certain URL is the best way to protect yourself against this. All right. Missing, this is again, very, very much related, missing function level access control. So you might go to a site, for example, and the site says here something like site.com/user. Okay? Sorry, /user. So, and in the websites, you have links where the user can click to go to other parts of your web application. And here again, developers, they have this misconception that, which is known as security by obscurity. They think in their mind that if the user cannot see the link, they don't see the URL, then it is secure. Okay. So because there is no link in the user URLs that says /admin, for example. But they are not aware that users could be either curious or malicious, and they can guess URLs. They can go, instead of user, they can try admin, they can try manager, they can try other paths. Not only this, there are tools out there, web application scanners. They can discover all the URLs of a web application. So don't rely on security by obscurity, but always check the authorization whenever the user requests a URL. Don't rely on the fact that, oh, the user cannot see this URL. then they will not be able to access it. That's not correct. You have to always, don't be lazy and just check the authorization whenever the user requests any URL, check that they have really access to it. Yeah. Okay. And sometimes, remember, sometimes it's add user, they might say add edit user, update user, delete user. They can try other alternatives. Okay. So I hope this is clear. This is just another example of missing function level access control. So instead of doing user, I can do admin, I can do manager, and I can try other alternative URLs. So broken authentication or broken access control, is this clear? Like users can be either curious or malicious, and they can start changing URLs. And they can, even if they are not visible to them in the user interface, even if you're not providing an explicit link, the user needs to click to get to that location or to that resource, they can guess it in and manipulate the URL. So always check authorization before you allow the user to do any action on your website. Okay, the sixth threat or common threat that's found in web applications is security misconfiguration. Security misconfiguration. This one is very typical. You know, when we buy, let's say, a router or switch, we just bring it home, we plug it, and we start using it. Okay? Maybe it has some default password. We never bother changing such passwords. So anyone, you know, they might find all the brands of let's say, routers, and they can just look up. You can look up the internet. You can say for a Cisco router, this number, what is the default password? For this brand, what is the default password? And you can just look up all the default username and passwords. Sometimes they are the same, admin, 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 or admin, admin password, something like this. You can just try them. These are examples. Sometimes we install software and it has some default username and passwords, and we don't bother disabling that default account or adding a new account. So never just install something and leave it the default configuration. That creates vulnerability. Not only this, sometimes in the context of servers, we install a software and it has so much other stuff that we are not using. It might have some other components we are not using. Some ports are open that we are not making use of, and we just do the default installation because it is easy, just install all. We need to be very, very careful here because those can be abused and you are opening door to misuse and attacks. So in here, luckily here in the real world, there are many tools out there that allows us to scan our network and our servers to find such default configurations, and it can alert us to do what is known as hardening the servers, making it hard to kind of abuse and misuse such servers. And the way to do this is you disable any unnecessary packages, accounts, processes, services, anything you don't use, disable it or uninstall it. Disable default accounts and use your own accounts, add new accounts. And always make sure the servers are patched and the server are patched. Any updates to your operating systems or servers or components you are using, you're always catching up and updating those. Okay, security misconfiguration. I think it's easy to understand. Cross-site scripting, number 7. This is very, very common and very dangerous as well. Cross-site scripting. Any idea what this means? Okay, very good. Yes, so let me give you an example, just to bring this closer to your mind. Let me just restart this app. Okay, I'll go here. So what I will go here, I go to profile. Let me log in. Okay, profile. It's very nice website, but it's full of vulnerabilities. Unbelievable. Okay, so let me just remove this guy. So this, whatever. This is supposed to be the name of the user, the first name, the last name. Everything is fine here. Now, what cross-site scripting means, there are many scenarios, but this is one common scenario. So what I will do here, there is a field which it is expecting a string, which is supposed to be the first name. So instead of putting the expected data, I am putting a malicious code. Typically, in this case, JavaScript code. Because this cross-site scripting, it does not run on the server. It's not targeting the web server. It's targeting the client. So what I will do here, I put some malicious script there, and this malicious script will go and will be stored in the database. So the first name of this person, instead of being Ali, it will be script. Now, when the user come back to this website, you see here, it says here Ali Dom. So what will happen is the system, instead of showing this name, it will go ahead and execute that script that was assigned to the first name. Yeah. No, this one is called persistent. It will be manipulating the DOM, but this one is even worse because it will be persisted in some database, and it might impact many other users. Let me show you another scenario just to give you an idea that this can be inflicting damage to many people. For example, let's say we have a job posting somewhere. Somebody is supposed to be posting the job description. Instead of doing that, they post a malicious JavaScript code in the job description. Yeah? And this job description will go to some sort of database, will be stored, and then people looking for jobs, they will come and search for jobs. So when they will get back this job description, it will have some malicious code. When the browser renders it, it will execute this code. Yeah? And this code could do a lot of damage. Least thing, it can deface the application. Deface means it can add some inappropriate content. It can steal the user cookies. It can do a lot of damage. Okay, so let me show you now a concrete example. Okay, so first of all, have a look at this. You see this profile here? You see the URL? What is the URL of this link? It's a localhost/profile. I mean this one. You see it? This is pointing to localhost/profile. So what I can do here, okay, I'll just pick up this here. Yep. Okay, so what I'm doing here, I will go to this, those of you familiar with JavaScript development, I can manipulate the DOM. I can change the document on the fly. So in here, all I'm doing, I'm going to this profile menu link, and I'm changing the link to point to this evil website. Okay, for example, this is just a small example. So let me copy this, and I'll paste it here. Okay, so this is the cross-site scripting. So what will happen to this script? It will be stored in the database in the profile of this user. So let me now save it. Of course, Chrome will say, oh, I discovered the cross-site scripting going on. But still, it took place. Let me go back. And let me see the profile here. Let me just refresh. Oh, sorry. All right. You see the profile here? You see the profile where it's pointing to? The link in the profile. So now whenever somebody visits this website, they will have this link changed to, it will take them to some malicious website. I can see here, if I click here, if you do this at home, it will go to that website directly. But in here we have another level of protection, which is the web firewall. So because that, based on the name, the ITS has configured some rule in the web firewall to deny access to this page. This is just to show you in security there are different levels of control. So the attacker managed to do cross-site scripting, but we have another control that protecting us. But if you are at home, you don't have this web firewall, which will just go as an example. So this is just an example. Let me show you another one of stealing the information. So let me just copy this guy, take it here. This is the local storage ID token. Of course, the browser detects that this is cross-site scripting, but the damage will be there already. When I go back to the website, it is revealing to me this access token. I can make use of it. Now, those of you familiar with the JavaScript, they know you can very easily, in few lines of code, you can send this to another server, to another person through the web. Yeah, and they can get this. Imagine this is your authentication token, or imagine this is your session ID. The attacker can take this and create another browser session, create a cookie, and then they can hijack your session. Yeah, this could be very dangerous. So this is just to bring the idea closer to your mind what this cross-site scripting really means. So you're taking some input from user. That input is a malicious code, and most likely maybe you will store that malicious code in your database. Future visitors will get that malicious code. It will be executed in the website, and because it is executed within your website, that code is trusted. It can do whatever genuine code the developer has wrote. This script can also have access to everything. It has access to your cookies, to your local storage, to everything on the browser.
So it implements hijacking and injection?
In here, in here, now, in that script, your imagination now is the limit. You can do whatever you wish. Deface the application, put some inappropriate content. You can even ask the user to log in. You pop for them a username and password, ask them, please log in again. We want to know who you are. They log in, you take their credential, and you send them to the attacker. And the attacker will go and this is very dangerous. It can do all type of damage. Is clear?
Why the script will be cheap for all of the users? Because it was stored by creating a certain user.
Okay, very good. If it is for certain user, yes, it will only show for this user, for example, for the profile. Let's imagine this one. I'm putting a job post. How many people are looking for jobs? I guess many, yes? All of them, they will get this. Yeah? Okay, any other question? You might put this in a blog, in the comments, for example. Anybody come to that blog, that script will be executed against them. Yeah? How do we solve this? Very simple. What is it? What's the name? Input validation. Input validation. The other thing you can do to make this harmless, you do encoding. Let me show you. In programming, it's one line of code. Not even one line, half line. But the lazy developers, again, they don't do it. It's called encoding. So let me show you what this encoding means. HTML encoder, okay? So I'll go to this encoder, just type in my script and encode it, which means any input from users, I will always encode it. You see here, this is encoding. Basically, the less than, the greater than will be replaced by these other characters. Now this becomes harmless. Even if the attacker managed to send this on the server side, we will encode it before we store it. Then it is harmless. Have a look. Harmless, no problem. It will say, oh, your name is script local alert. It doesn't matter, but it's harmless. It does not execute. Is clear the idea? Okay. So validation. Validation is the most important protection mechanism here. Moving on, this is what I mean by defacing. They can put some inappropriate content. They can ask for login. They can do all type of evil stuff. Insecure deserialization. This is very similar to injection. Remember injection, where the user type in some malicious code instead of in some text boxes? Same thing here. They might send you some object. Those of you familiar with JSON object as an example, they might send you a JSON message that has a document. Inside that document, some of the properties could be set to malicious values, or they could be set to malicious code. So let me give you just a small example. You see here, you might have a message received, like the user is sending you a JSON message. So this time they go ahead and take the message and change some of the properties. Here is an example. You see here username equal. Those of you attended last time for SQL injection, this is how we can do SQL injection. Especially if you are doing concatenation here. So I'm closing the quotation and then doing OR and putting an always true condition. And then basically what this will do, if I'm concatenating this with a query, this condition will always be true, and basically the system might allow me in or give me what I asked for. So SQL injection or injection in general, it does not happen just through the user interface. It can happen even objects that are sent to you using, let's say, JSON or XML or any of the data format. When you deserialize them, you have to be careful also, because the properties in this document that is received by you might have some malicious data or some malicious code. So in here, you need to be very careful and to do message signing. Whenever you send a message, to make sure that the message has not been tampered with along the transit. And also make sure you do validation. So do validation not only when you receive input through the user interface. Do data validation even if you receive an object, serialized in XML or JSON. Don't just take the object, trust it, and process it. Do validate it first. Okay, this is another one, number 9, using components with known vulnerabilities. And again, those of you who did any reasonable development, they realize maybe these days we only write maybe 20%. 80% is coming from other people. We reuse many components. And guess what? Any vulnerabilities of those components, you inherit them automatically. Yeah, if those components are attacked, your application can be attacked. So in here, how to solve this? You need to be very careful when you choose the components you use. Choose something well-known, well-tested. There is a large community behind it. If there is any vulnerability, they quickly fix it, and of course you need to keep up and update the components. Don't use something unknown, nobody heard of, not many people using it. It might have vulnerabilities, and you will inherit those vulnerabilities. So using components with known vulnerabilities is very dangerous, because these vulnerabilities will be known to the attackers and they can come and misuse them. Last one, number 10, insufficient login and monitoring. This is very typical. Like there is no login and monitoring of security events. For example, there are failed login attempts. You don't put them in a log. Like somebody is trying to do brute force, you are not aware of it. So basically, any security relevant events such as failed login should be logged, basically written to a file or database. And this log should not be forgotten about. Somebody must be looking at these logs regularly to see if there are any attempts and try to protect yourself further. So also, you are not using any monitoring, such as an IDS system, for example. You know, if there is an attack and somebody is stealing lots of files from your system, you might see a more outgoing traffic, an abnormal outgoing traffic compared to the normal. So you need to have some kind of monitoring to be aware of any ongoing attacks. And in reality, people have done studies And they found that on average, it takes 200 days on average to find that the organization is under attack. This is just to show how ineffective logging and monitoring is. So people are not monitoring, attackers are still there doing their work, exploring the network, stealing information, downloading things, and we are not even aware that they exist. So this can be solved, of course, by doing monitoring of logs, monitoring of resource usage. If you see suddenly all your server becomes 90% usage, 80% CPU for a long time, there is something going wrong. You used to, let's say, on average per day, let's say 10 gigabytes of network usage, suddenly it jumped to 100. There's something wrong. Something is going there. Something. So you need to monitor these health states and investigate. And IDS, the intrusion detection system and intrusion prevention system, could help you do this.
Like the anomaly based?
Yes, the anomaly based or the behavior, the signature based. Both of them, they could be very, very helpful. Plus, in some custom applications, you need to log those events and investigate them. So that's it. This is the conclusion. So us as developers, we need to understand these threats. You saw that many of them can be avoided through validating user input. Very, very important to validate user input, and don't trust the user input. Always validate it before you use it. Don't fall into this misconception of security by obscurity. If the user does not see it, means it's secure. That's not true. And so if you are using, let's say, Node.js or Java EE, any platform, you will find the nice recommendations, especially from OWASP. This OWASP project has so many valuable documentations out there specific to your platform, because there are generic vulnerabilities and there are vulnerabilities specific to each platform. And finally, make use of vulnerability scanning tools. There are many scanning tools out there that you can make use of to help you discover these vulnerabilities and fix them. Okay, thank you very much. It has been a great journey, a challenging one.